best of this hour. As you can see that like few students are just about to join us. So till then, we can do one thing. Like we can take few minutes to introduce ourselves and we can go around the virtual room. And each of you will have a chance to share your name and your grade level, please. See, electricity is a really important topic of GCSE. If you're in like year 11, you're in year 10 or like 9, and all these 3 years, like this topic is really, really important. What we do is basically we do basics in some year, and later on we just keep on including more topics in this. And this starts becoming one of the important topic of physics. That's the reason I have selected this topic to make it a little easy for you people so that you don't feel afraid of this. So today we are going to do the basics of this. I mean, electricity is really wide, but today we'll be covering the basic things. So do you have any idea what electricity is or why do it is important for us? Yes, any one of you? Can you please tell me any importance of electricity?
Electricity. Without things like electricity, then we wouldn't be able to supply most things with energy. Like,
Exactly. Yeah, that's right. Even the best example right now is that without electricity, it was not possible to connect with each other, isn't it?
yeah,
Yeah, so this is the most like current example we are having right now. So in this topic, we are going to cover like our learning objectives are going to be what exactly electricity is, what's the history and the types of electricity, and what are the electrical circuit components we all see, like what are the importance, what actually they are, their function, and what are the electric circuit types. Okay?
yeah,
Yeah. But before moving to that, it's really necessary that you must be like a little bit aware of the basic things, that is charges. Do you know that there are 3 charges in an atom? Yes.
yeah,
Okay. Still, let me give you a little idea about all the 3 and then we will move on to the next thing because this is the basics that we're going to require and throughout the session. So if you look at electrons, electrons is represented by like this symbol, and electrons is a negative charge. Electron is a negative charge, and the charge over it is like negatives of 1.6 times 10 raised to the power 19 coulomb. Because we all know that we always calculate charge in coulombs. Okay? Then
yeah,
we have protons. They're represented with this P. That's a positive charge. And the charge over it is like positive of 1.6 times 10 to the power minus 19 coulomb. Can you see something that the value of the charges is exactly equal of both the charges? If you look at electrons, the value is negatives of 1.6 times 10 raised to the power minus 19 coulomb. And the value of protons is like 1.6 times 10 raised to the power minus 19 coulombs. The values are equal. The fact is, they're just different with the powers. Like one is in negatives and another one is in positive, right? Yeah.
yeah,
So there's a hint and there's a way you can remember uh, like how to remember the charges. Sometimes students get confused how to remember that which one of the charges like positive, which one is negative. Before that, neutron is something that is neutral, that doesn't have any charge on it. It's neutral and value is 0. Now, as I said, some of the students get confused with the thing like which charge is negative, which one is positive, and which one is neutral. So there is a very short trick to remember this. You don't have to memorize it. You just give me a second and you'll get to know what it is. Okay, write down capital P. P refers to proton. And again, P stands for positive. Do you agree with this fact? That both the terms, like proton and positive, they start with P. And this is here. Protons is a positive charge. So you don't have to cram it. You just memorize it that both the things starts with P. That means the one proton is positive. In the same way, we have a neutron. We can write down a capital N and then neutron. And also, the neutral term starts with N only. Here you can see the proton is positive. Both of them have a same initial alphabet. In the same way, neutron is a neutral charge that's at 0, and they both start with a neutral, that both start with the same alphabet again. And the remaining one, that's an electron, is negative charge. Okay? I hope this will help you a lot. Is it clear now?
Yeah.
Yeah.
Okay, that's great then. You can just write it down so that we can move on. Please write it down. Yes, students, write down the information from the screen. It is going to be really helpful for all of you. These are the three charges that we'll see in an atom. See, every matter is composed of atoms. An atom, if you look at the structure of atom, they contain three charges: electron, proton, and neutron. And these are the values of those charges. Like electron is your negative one, proton is your positive one. The charge they have over there is like 1.6 times 10 raised to the power minus 19 coulomb. And I gave you a short trick to remember which charge is positive and which one is neutral. And the left one is your negative charge. So, done?
Almost.
Okay. Okay. Can we just move on to the next slide? Yes, Sharon, it seems like you're writing.
Done.
Okay, once you're done, just let me know. These are basically the basics thing that we really need to know before moving to the main topic, that's electricity. And now we will be moving towards the main topic that we're going to cover today, that's electricity. Okay, I'm just moving on to the next slide. Yes, students, the main thing that we're going to cover is electricity. As I asked you in the beginning, what basically electricity is, basically I don't get any answer out of you all, but okay, I'm there to tell you, don't worry about that. But yeah, I got an example of this, like what is the importance of electricity? You gave me an example for that. So, but we will move on to the example later on. First, we should be clear about what exactly electricity is. So, dear, electricity is nothing but it's a form of energy, right? It's a form of energy, or you can say that it is the flow of electrons. It is the flow of electrons. Now, how a flow of electrons creates a current or electricity, I'm going to explain you. Okay. So dear, we know that every matter is made up of very tiny, tiny particles. Okay, that's your atom. If you look at the structure of matter, they all are composed of tiny, tiny things. That's an atom. An atom, if you look at the structure of atom, it contains a center and a nucleus. What does it contain? A center, and center is the nucleus and shells around it. We also call it as clouds. So every matter is composed of atoms. Atoms can be further divided into two parts. The center one, which we call nucleus, and the clouds or the shells around the center. The one nucleus contains two charges in it. The one is the proton, and another charge that is present in the center of any atom is your neutron. Okay? And the one I'm calling shells or clouds, that contains the third charge, that is your electrons. I'm writing the charges in bracket. Protons, P stands for proton, P stands for positive. Neutrons is like your neutral. Electrons is like your negative charge, right? And as I said, if you go back to the thing you just wrote it down, if you look at the values of the charges, the value of the positive charge is exactly equal to the value of the negative charge. That means negative charge of electron is exactly equal to the positive charge of proton. So we can say that number of electrons is usually equal to the number of protons in an atom in a normal situation. I'm writing this thing so that you can write it down. Usually, number of electrons are equal to the number of protons. Okay, dear? This situation is for like a normal situation when there is no external force, nothing like that. This is something when your atom is neutral. Why we are calling it as neutral? Because we know that the charge of electron and the charge of neutron is equal in numbers. It's just the fact one of them is negative and the other one is positive. So they will cancel out each other and your atom will remain neutral. There won't be any charge on it. But sometimes when there will be some external or, unbalanced force from outside that causes imbalance in this thing, what it does is your atom now tries to either gain an electron or to lose an electron. So in the influence of external force, like electric field, your atom will either try to gain electron or either it will try to lose electron. So whenever an electrons are lost from an atom, the electron will try to move towards the electric field. And that causes in the movement of the positive charge opposite to the direction of the movement of negative charge. And that's what makes your electric current. Is it clear? Yes. If any one of you is having any doubt in this, you can ask. You can write it down in the chat box. Your queries will be resolved right now. Or if you want me to write it down, I can write this stuff on the screen. Yes. Yes. Do you want me to write this thing? The thing just I mentioned right now, what exactly electric current is?
Yeah.
You want me to write it down?
Yeah.
Okay, I'll do that. Don't worry. Because of external force, the atom will either try to gain or try to lose electron. Situation could be any of them. Okay, they can either try to gain it or lose the electron. Can I turn my slide? Is there anybody who is still writing from the screen? Yes, dear, just let me know about this. Okay, I'm switching to the next slide then. Okay. So, okay, do you want me to write the whole thing or it's just enough for this?
Yeah, that's enough.
Okay. Yeah. Let's move on to a little bit towards the history of the electric current. Then we will come back to the electricity, but it's necessary. See, it's like having electricity is a feeling of blessed, right? We're totally blessed to have this thing. It's the biggest gift ever we have got. The reason for that, everything is working on electricity. Either it's your mobile phones or it's your laptop, it's a light we're living in, like we use every other thing we're using in a daily routine, everything works on electricity, right? So can you just think about the era when we were not having electricity in our life? We were not at all familiar with the fact that there could be something like this which can help us to run every other equipment. Yes. Is there any idea? Can you just tell me? How was the life before electricity? See, we got this thing in like 1700s. We got this thing in 1700s by the scientist Benjamin Franklin, the one over here, the scientist. So we should be really thankful to this scientist and we should at least pay tribute to this one. He was the one who gifted us electricity. At least we all should be familiar with the name of this scientist. So it's Benjamin Franklin. Is any one of you aware about his experiment?
Was it the one where he was,
Yeah.
I think it was a kite, where he
Okay.
was flying it. Then all of a sudden electricity struck. Then he started to wonder, what does the cause of the lightning that had struck his
Yeah.
so then that's how the electricity was later then discovered.
Yeah, that's great. Yeah, that was this experiment of Benjamin Franklin. Yeah, great. That's great. Yeah. So it was one Benjamin Franklin in year 1700 who introduced us with the concept of electricity. He was the one who discovered this fact from an experiment where he tied a key, like a kite with a metal rope, and he flew it in the like this time when there was a thunderstorm in the sky. And when the electricity struck on the kite and there was like lightning all over there he related the concept of the static electricity with that thunderstorm lightning. He analyzed that there is that these static electricity and the one that is in the sky is somehow same, right? This is what he got an idea by that experiment. And can you tell me one more name from the same thing who gifted us the concept of electromagnetism?
Is it Nicholas Tesla?
No, you have to move a little bit like closer, but not that. It's like Michael Faraday, who in year 1820s and like in between 1830s, he discovered and he gave us the concept of electromagnets that we can make electricity with the help of magnets too. So both of them are like really helpful to us because of them only today we are having this thing that everything is working on electricity and everything is so comfortable to use, right? Can you
Yeah.
tell me one thing? If I ask you to think about the era when there was not electricity, like no electricity at all, so how people were surviving on that situation? What was the
Mm.
source of like everything? Yes, anybody?
Uh, uh,
Okay, it's okay. Let me
Miss,
tell you.
what was the
Yes.
question again?
Yeah. I said, can you just tell me about the situation when there was no electricity at all? So
Yeah.
how people were surviving? What is the way they were surviving? Let's say nowadays we definitely need light for like doing any work at night. We definitely need things that can warm our room. We definitely want to store food in a quick cooler area. So like we don't have electricity we can't really use the refrigerators, we can't really have the bulbs. So how those people were surviving? Yes. Yes, Toby.
Uh, do they use like woods to like
Yeah.
create fire?
Yeah, that's great. Okay, that's a way to warm your room. That's great. Okay. What about the lights?
they use
Uh,
Yes.
like they use like candles.
Yeah, that was also one way. They used to use like oil lamps, candles, because it was not a fact that at that time also people will wrap it up. Okay, we're not going to do anything in the night. No, in that situation also people were working at night, but the source is something else. The source is like oil lamps. They used to use wood, as Toby mentioned, for like keeping the room warmer. They used to keep like ice bags for keeping things cooler. So this is how the people were surviving, right? Okay, let's move on to the next now. Let's come on to the main thing, that's type of electricity. As I said, like Benjamin Franklin related that static electricity is somehow same as of your like the one in the sky. So before moving to that concept, we should be aware about what exactly static electricity is. See, we have two types of electricity. One is your static electricity, another one is your current electricity. Okay. So when electrical charges develop on the surface, please underline the point. When electrical charges develop on the surface of the material, that too caused by friction of two or more materials because of rubbing together, that is what your static electricity. This, the kind of electricity generated over there is an example of your static electricity. Okay. And how you will come to know that there is something now, like after rubbing two materials, how you will get to know that there is some electricity over here? That is, you'll feel that the objects may be attracted to each other or may even cause a spark. You must have noticed is sometimes like sometimes our hair causes a spark, right?
Yeah.
yeah,
Yeah, that is because of rubbing of two objects. For example, I can give you an example of this situation. You can try that. Like, I don't have equipment right now. I was planning to do that, but I just forgot at the last moment. But you can do a very easy experiment for that. You can keep a balloon in your one hand and a sweater, like a woolen sweater in another hand. Try rubbing them with each other. Rub them for a few seconds. Keep on rubbing them. After some time, what you will realize that there will be some sort of attraction between both the things. Also, you may hear some spark too. So, do you know the reason for that? Why does that happen? Yes. Do you know the cause of static electricity?
Is it
Like,
because when you're rubbing the two objects together, so what happens is that there are charges on one object, then charges on the other object. So when you rub those together, then the charges from one object go to the other object when you rub it.
Yeah, that's right. Great. You're really great with physics. I must appreciate that. Okay, the experiment was rubbing a balloon on a woolen sweater. So if you look at the situation, before rubbing, the charge is neutral because balloon is having its own charge, your sweater is having its own charge, and both of them are having a neutral charge over them. But once you rub them, by the time you're rubbing them together, the charge gets exchanged, right? Can you tell me which one of them become negative and which one of them become positive? Before rubbing, both of them are neutral. They don't have any charge over them. But after rubbing that, there will be some sort of charge on balloon and there will be some sort of charge on woolen sweater. So any idea about the charge?
So when they're neutral and then you rub them together, then what would happen is that some electrons from the atoms on the charges in the sweater and balloon would jump to so the charges on the balloon would jump to the sweater, which would make the sweater more of which would make this sweater gain which would make the sweater
It seems like you're a little bit different way. You can correct yourself by looking on the screen. I have written the exact concept. See, when you're rubbing balloon in a woolen sweater, what really happens is, before rubbing, they were in a neutral situation, but after rubbing, one of them gains a charge, one of them like becomes negative, one of them becomes positive. So one, like the balloon, what it does, it gains electron from the woolen sweater. And because the one who gains electron becomes negatively charged, and the other one, which loses electron, becomes positively charged, right? So the balloon will have negative charge over it, and the woolen sweater will have positive charge over it. And this is what we call static electricity. I hope this is clear.
Yeah.
Okay. So can we move on to the next type of electricity then? Yeah, the next type of electricity that we have is a current electricity. Yeah. Basically, the current is nothing but a rate of flow of electrons. And it is produced by moving free electrons. As I just told you about this concept in the beginning of the session, how it really happens, how electron starts moving in a matter. I told you that. So we measure currents in ampere and we represent it with a capital A. Measuring current means like the way we can measure the weight of a body, we can measure a distance in meters. In the same way, we can measure the intensity of current. And to measure that intensity, we have a unit that's in ampere. Okay? So when current electricity is the flow of electric charges across the electric field, I told you that once like there will be some external force like electric field, the electrons will start moving towards the electric field and there will be a flow of positive charge that is going to be opposite to the electrons. That's what makes an electric current. Okay. But unlike static electricity, if you look at static electricity, there is no need for having a conducting material at all. But in current electricity, the flow must be through a conducting material. Okay? Is it clear or is there any doubt in this?
It's clear.
Okay, that's great. See, there is a one term that is conducting material. Conducting materials are those materials that can allow the flow of current through them. For example, metals. If you look at the object like wood and paper, they doesn't allow the flow of current through them. Now in electricity too, we have two types of electricity. I'm not going to make this session a really long one for you so that you will start feeling boring. So we are going to end up after this. So before moving to this, I would like to tell you something. See, this is how we do in our sessions. Everything will be taught to you in a detailed manner. It won't be considered that if you're a student of 11 year, if you're a student of year 11, I will not say that you should be really clear with all the basics before coming to me. No, that's not necessary. It may be possible you would have some sort of situation in your school or your time was not that good. So you're not really clear with your basics. So don't worry about that fact. I'm here to clear all your basics. Doesn't matter if you're a student of year 9, a student of year 11. I'll start from the basic so that you don't struggle in the further concepts. Along with that, you'll get all of your notes, like all the notes on a particular topic within the session. You don't have to search here and there. You don't have to move on to other things, other sources, because that is just a wastage of time that I never want with my students. I don't never want them to struggle with things. Because if you go to the other sources like internet and all, there is a lot of stuff to do. And I have seen students like making notes for one topic for a whole month. And at the end, what they realize is now they have so many topics and they have a little bit of time. So again, a time management is again a really, that's what I do for my students. You don't have to struggle. I'm there to manage your time. I'm there to give you all the notes. I'm there to give you the type of questions you're going to have in your exams. That will be done through mocks. So after every session, I give questions for homework so that you can analyze yourself. You can have a look at the topic, like how you have done in the session. Are you able to answer with that? After every 2 weeks, there will be a test that will help you to assess yourself, that will help you to direct yourself, like what actually you want. Where are you struggling? Like, are you clear with the concept, but you're struggling with answering skills? Or are you clear with the answering skills, but you're not getting the concept? So that will help you in that way. Okay, dear? So before ending up the session, let's have a look at the last concept. Yeah. So electricity can be divided into two types again. Your current electricity can be divided. See, I'm not dividing static electricity into types. It's your current electricity that can be divided into two types. One is alternating current, other one is a direct current. So alternating current is something that doesn't have a fixed direction. It's like fluctuating all the time. The directions keeps on changing every time. Okay, so you can see this kind of current in your sockets, in your switchboards at your home. The electricity that is present in your switchboards is an example of your alternating currents. Okay, and the other one, that's a direct current, in short, we call it as DC, is the one that have only one direction. It travels in only one direction. It travels only one direction, whereas the AC moves back or forth. AC always keeps on changing its direction, but direct current, it's like that is always in one direction. Example for alternating current, it is present in all sockets of your home. Whereas if you look at DC, it's energy from a battery. I'm writing here. Energy from battery. Okay. I hope this one is clear.
Yeah.
Okay. Yes, Toby, what about you? I hope it's clear to you too.
Yeah, it's clear.
Okay, that's great. So that's all for today's session. I hope you like it. See you in the next coming live sessions. There will be more sessions like this on like really important topics of GCSE. Hope to see you there.